Hi OSLO users, in this video I'm going to talk about the central reference ray mode out of OSLO's ray aiming modes. This is the default in the program. A lot is gained with the central reference ray mode without a lot of expense. In other words, we are not losing much speed at all and we are gaining quite a bit, which is why this is the default. And this mode works really well with vignetting factors that is shown in another video in particular. So if we go to the online help, it's not the most helpful part of this. It says central reference ray mode, says it's default, and the ray bundle is centered on the reference ray. And the reason why it points to the optics reference is because you have to understand reference rays and lots of other sorts of things. So I will go to a version of our optics reference. So this talks about the ray aiming in particular, and what this discussion generally does is it talks about what happens if you have a stop at different field points that is shifted laterally. I tend to think of this a little bit more easily as a longitudinal shift. I'll show that in a moment. This is a pupil aberration, and what this is going to tell us, what this optics reference tells us, it gets into a lot of the details of how the rays are aimed, what ordinary rays are, what reference rays are, and all this kind of stuff. We've got some other supporting videos for this material as well. Please look at our kickoff video for this ray aiming mode to see all of that. But I think it's easiest to understand by looking at an example. So that's what I'm going to do. So this is a demonstration triplet that's been modified from what comes in the program. Please watch the entrance pupil ray aiming mode video if you'd like to see what I've done to the lens. So this is effectively the same lens. I've got it set right now where we are in the first configuration of the two. I want to look in the second configuration, and right now this has been kept as a in the entrance pupil mode is how this is set. So it's aiming for the paraxial entrance pupil. So what we want to do now is we want to actually set that. It doesn't allow me to change that when I'm in the second configuration, by the way. That's what that issue was. We go to the central reference ray. So when you start a new lens and if you've changed nothing, this is the mode that it's going to set it on. And now if I come here, I want to go back to that second configuration, which is only showing these rays in the center. When I look at this now look at this. It's actually correctly making sure, I should say, that these rays are going through the center of the stop. That's what we've gained. In the previous mode, let me just show that again because I think that's really critical to see. So you can look here. Let me zoom this up. You can see all these rays are going right through the center. If we look at the total, all these rays are going right through the center. If we look at all the bundles, you can see there are still some things going on out to the edges. You can use vignetting factors to help with that and still keep things nice and efficient, or you can go to something like wide angle mode if you really want to do more. I'll do that in another video. So you can see what we've gained here is these are all going through the center, because if we go back to the entrance pupil mode, so here I switch to the entrance pupil mode and we take a look at it, you can see now they are not all going through the center. So this is making sure that the rays that are the reference rays defining the beams are at least going through the center. What happens if we have this kind of aberration, this sort of pupil aberration, is if you look at the location of the stop itself, notice these are shifted up and down, and that is part of the discussion that's done in the optics reference. I think it's a little bit hard to understand it when you haven't seen it in the code, which is why I'm choosing to show it this way. So the main message here is entrance pupil mode is not really that good for covering this sort of situation and is very limited. And with just a little bit more computational overtime, just by taking and making sure we iteratively trace the central rays for each field point, we can gain a lot because we're at least getting ourselves to go through the center. And then with vignetting factors, we can get much closer to accurately modeling the pupil without any additional computational overhead. So this is a nice way to run to keep things good and efficient, and is useful in many cases. So I hope you've enjoyed the video.